In question 18 we're given an equation for y, which is a cubic equation, and we're asked to find dy by dx, the differential of this equation. So dy by dx of that will be 3x, sorry that's badly written, 3x squared. So of course you take the front number to the, so you take the power to the front and minus 1 from it, 3x squared minus 8x plus 4. Let's write that here, just 3x squared minus 8x plus 4. In part B then, we're told that the diagram shows the sketch of that equation. Point P is the turning point. Now what's important about a turning point is that the gradient at that point is 0. So once it turns, as it's on its way down for example, the gradient's negative, on its way up it's positive, but at that point it's 0, and the same goes for that one there. In part B we're asked to work out the coordinates of P. So since we know that at that point the gradient will be 0, when you differentiate an equation, dy by dx is in fact the function to work out the gradient. So what we know therefore is that 3x squared minus 8x plus 4 is equal to 0 at that point. Factorizing this then gives us 3x, x here, minus 2 and minus 2. And we know that's equal to 0. So based on this, we know that x is either equal to 2 over 3 or x is equal to 2. And again, this 2 over 3, just to explain that, when two numbers multiply together to give 0, one of them can be 0 or the other can be 0. So that means that either 3x minus 2 is 0 or x minus 2 is 0. If 3x minus 2 is 0, that means 3x equals 2, therefore x equals 2 over 3. Subsequently, if x minus 2 is 0, therefore x equals 2. Now, if one of the x values is 2 over 3, the other is 3, since 2 is greater than 2 over 3, we can see that there's one turning point here, there's one here. If 2 is greater than 2 over 3, that one must be 2, that one must be 2 over 3. So we know therefore the x value is 2. When x is 2, we substitute that into the original equation. So what we do is we substitute that value 2 into this equation here, and what you end up with is 2 cubed is 8, minus 4 times by 2 squared is minus 16, plus 4 times 2 is plus 8, and then of course 3 is just 3 on its own. And what we can see from this is that the 8 and the 8 and minus 16 will cancel, and we'll get left with 3. So that's part B. We're then asked to write down the range of values of x for which the curve has a negative gradient. Now, since we can see that there's two turning points, i.e. two places where the gradient is 0, those places are here and here. At this turning point we go from negative to positive. At this turning point we go from positive to negative. That means the only two places where this curve has a negative gradient is between those two places there, between 2 over 3 and 2. Therefore, that means that the range of values of x for which the curve is negative is between 2 and 2 over 3.